When Docker is installed in your operating system, it runs more or less in the background, and then you communicate with it using the Docker command line program or their graphical interfaces to interact with Docker. But if you use the command line, then Docker is the name of the command, and then it takes a subcommand like image or container, and then image takes subcommands like ls. So ls lists all of the images that are currently installed in your Docker system, in your particular operating system. And you can see in this case there are some images that are named Debian Testing and Ubuntu 18 and so on. Each of these images has an ID that locally distinguishes it, so you can use either the repository and tag as a name or the image ID as a name. These are the images that we can start with, and then we can create containers from those. Docker container ls will show you all the containers that you have. If you leave out -a, it only shows you the running containers, but with -a, it shows you all the ones that you've created and maybe stopped, but have not thrown away yet. So we'll talk about how you create a container from an image in a moment. Where do these images come from? In general, they come from Docker file scripts. So this is an example of a script that starts with a Debian stable slim image. So every Docker image starts with some existing image, and then it runs commands within that image to build up a larger image. So here it's installing some more packages, it's installing some installer script here, setting some environment variables, and running a startup command. So this Docker file is run once to create a new image, and then containers can be generated from that image. And if you're wondering where Debian stable slim came from here, this was fetched from Docker Hub. So that's what Docker does by default. As the hub part of Docker Hub suggests, it's kind of like GitHub, and that it's a repository of images that can be quickly fetched by anyone who wants to use those images. When I create a new image with this Docker script, of course, I'm running a few installation commands here and setting up a few environment variables and so on. The resulting image is going to be pretty similar to the one that I started with in terms of the content of the file system. And so Docker makes this sharing lightweight. It will keep the original image plus my changes here, a kind of diff on the file system, to compactly represent that information. So it's relatively cheap to make these new images that are derived from existing images. To create a new container from an image, you can use Docker run, and IT here means connect it to, make it interactive and connect it to a terminal, and this is the image name that it's using. Let's try this out on my Linux machine here. Docker run Debian testing. And it happens that I've run Debian testing on this machine before, so it quickly gave me a prompt back. This is a lot like SSHing into a different machine. But it's not a different machine, it's a container running in the OS of the machine I was already logged into. If I do ls, then you see a kind of typical starting file system. If I look at home, you see that there's no mflat, or in fact any users set up on this installation at first. It's just a raw operating system implementation. In fact, if I look at who am I, then we'll see that I'm logged into this container as root. And this is pretty typical, to use a container as root so that you can do anything that's allowed within that container without worrying about permissions so much. It's also common to create users within the container so that you can control and manage the processes that you run there. If I want to write to the root file system of this container, I can, since I'm root. So I'm going to touch a file called here1, and if I ls, then it's there. If I exit this container, the container still exists, but it's not running anymore. If I do run it again, then it'll create a new container that's again based on Debian testing, but you'll see that my here file is not here anymore. That's because it's a completely different container, conceptually a complete copy of the image that I started with. If I use Docker container ls, then we can see that I've created many containers. But you see I exited 5 seconds ago and 26 seconds ago, these two different containers, so they both exist and they're separate. If I want to resume this container, then I can use Docker start. IA makes it interactive and talking to the terminal again. And that's that container that I had created earlier. That's where my here file was, and you can see that it's still there. So you can create new containers with run, start them up again with start, and there are lots of other commands for controlling these containers. In that Docker run command, -I meant interactive, -T meant as terminal. Then I could start it again where -IA was like -IT, but you just use A instead of T for start. And we saw that different containers that I started from the same image, they have separate file system state. Again, this state is managed as a diff on the image state, so it can be compact and cheap to create these new containers.